When most people think of medieval technology, they imagine mud roads, crude tools, and people struggling through a world without modern science. But around the year 1200, a blacksmith could forge a blade with properties he couldn't explain. A builder could design a cathedral that still stands 800 years later. And craftsmen across Europe and the world were producing materials so effective that modern researchers are still trying to understand exactly how they did it. This isn't about magic. It isn't about lost civilizations or ancient mysteries. It's about something stranger and more unsettling than either of those things. Some of the most effective and impressive technologies in human history were built in the Middle Ages. So how did medieval people build things that even modern science struggles to explain? And how did that exact knowledge get lost? Medieval craftsmen had no laboratories, no written formulas, no modern scientific method. What they had was skill passed from hand to hand, generation to generation, through apprenticeships and guild traditions. Unfortunately, that system had one fatal weakness. When the knowledge skipped a generation, when there was no one left to receive it, it simply stopped existing. What we haven't been able to do, even after figuring out the science, is recreate the exact conditions that produced the original results. These technologies left behind sealed rooms, extraordinary achievements we can study from the outside but cannot fully reopen. Let's take a look at Greek fire. Picture a fleet of ships on fire. But it's not just the ships burning. The fire has spread onto the sea itself, blazing across the waves like it belongs there. The fire is literally burning on the water. It looks impossible. But the Byzantine Empire pulled it off and used it as a weapon for centuries. Sometime in the 600s, the empire discovered a mixture that caught fire and didn't go out. Even after it hit the water, they built it into pressurized tubes mounted on ships, set enemy fleets ablaze, and watched the fire spread across the water around them. That gave Byzantium an advantage that lasted for hundreds of years. But it created a problem too. If the formula ever leaked, that edge was gone. So they protected it like a state secret. Only a few people ever knew the full recipe, passed down by word of mouth, never written in one place. Here's what most people get wrong. They assume historians eventually cracked it. They haven't. Was it oil-based? Lime-based? Pressurized gas? Historians and scientists have tried all three. No one has gotten the combination right. The secret was guarded so well it outlived the empire that kept it. You can read every surviving record. You still can't rebuild the fire. Damascus steel is a different kind of sealed room. The story begins thousands of miles from Damascus itself, in India. There, skilled metalworkers produced a remarkable kind of steel, known today as woots. Woots was cast into small ingots and traded across Asia and the Middle East until it eventually found its way into the hands of blacksmiths in places like Syria. What happened next turned those ingots into legends. The blades they produced had dark flowing patterns that looked almost like water frozen into steel. They were strong without being brittle, flexible without being weak, and capable of holding a sharp edge far longer than many rival weapons of the time. But the blacksmiths who made them lacked modern materials science. They had no microscopes or understanding of chemistry. Instead, they judged the metal by its color in the fire, the sound of the hammer, and years of experience passed from one generation to the next. What they couldn't see was that tiny amounts of a rare metal called vanadium were helping create its unusual strength as it cooled. The same process that produced the flowing pattern also created the strength. Then the supply of woots disappeared as trade routes shifted. What connected the ore, the craftsman, and the finished blade slowly broke apart. The swords survived, but the process that created them largely did not. Still in the world of swords, there is another mystery: the Ulfbert blades. While excavating Viking Age graves across northern Europe, archaeologists kept running into the same inscription stamped into the steel: Ulfbert. The more researchers examined these swords, the stranger the story became. Many of the earliest Ulfbert blades had a carbon content 3 times higher than comparable European swords of the time, with far fewer impurities. The result was a blade that was stronger, more flexible, and less likely to fail in combat. The evidence points to trade networks stretching into the Islamic world, where high-quality crucible steel likely originated. The mystery wasn't that Vikings invented advanced metallurgy. It was that they had access to it. And then, just as suddenly, that access disappeared. As trade routes weakened, the quality of Ulfbert's swords declined sharply. New blades continued to carry the famous inscription, but many were made from inferior steel. The name remained, the craftsmanship remained, yet something essential had been lost. Sometimes a technology doesn't disappear because people forget how to use it. Sometimes it disappears because the world that supplied it is no longer there. For more than 800 years, sunlight has passed through the stained glass windows of Chartres Cathedral in France. Imagine stepping inside the cathedral on a bright afternoon. Blue light spills across the stone floor, washes over the walls, and fills the entire space with color. It looks almost celestial, the sort of light medieval people might have associated with heaven itself. The remarkable thing is that 8 centuries later, visitors are still seeing much the same light the medieval builders intended them to see. And for almost as long, people have been fascinated by one particular detail: the striking blue color. Many people assume the knowledge of Chartres blue has been lost. In reality, modern chemists have largely figured out how the glass was made. The famous blue came from cobalt mixed with small amounts of other minerals, creating a color that still dominates the cathedral's interior today. However, there's a bigger problem with the story. What disappeared wasn't the formula. It was the world that made it possible. Medieval craftsmen had access to skilled workers, enormous resources, and years, sometimes decades, to complete a single cathedral. Producing glass like this was expensive then. It would be even more expensive today. Just as importantly, tastes had changed. The great age of Gothic cathedrals had passed, and with it much of the demand for glass on that scale. In a strange way, that tells the same story as the other technologies on this list. Sometimes what disappears isn't the knowledge itself. It's the conditions that made that knowledge possible. The windows are still there, filling the cathedral with the same blue light they did 800 years ago. The knowledge survived. The world that produced it did not. Sometimes knowledge disappeared because it was kept secret. Sometimes because craftsmen died without passing their skills on. But medieval history also gives us a rare exception. Open a book written in 1206. Inside it, you'll find detailed drawings of machines that seem completely ahead of their time. Water-powered clocks, automated figures that moved and responded without a human hand guiding them. One machine even dispensed water for hand washing through a system of hidden floats and levers, triggering different movements at different moments. The man behind them was Al-Jazari, an engineer working in what is now southeastern Turkey. He didn't just build these machines. He documented every one of them in precise detail, diagrams clear enough that modern engineers have successfully rebuilt several of them centuries later. So his knowledge didn't disappear the way the others did. The book survived, the diagrams survived, the instructions survived. Al-Jazari's sealed room was never actually locked. The key was inside it the entire time. The world simply stopped trying the door. These 5 technologies came from different places: Byzantine naval warfare, Syrian blacksmithing, Viking trade networks, French cathedral workshops, Islamic mechanical engineering. Different cultures, different centuries, different problems to solve. And yet they all point to the same truth. These technologies were extraordinary, but the systems that sustained them were fragile. War, trade collapse, conquest, and neglect could wipe out generations of knowledge. None of these technologies were lost in the same way, but all of them were vulnerable to a changing world. So how did medieval people build things that even modern science still struggles to explain? Not through magic, and not because they were somehow smarter than everyone who came after them. They built them the same way human beings have always built remarkable things: through observation, experimentation, failure, and knowledge passed from one pair of hands to another. Some of the most remarkable things ever built weren't lost because someone forgot. They were lost because the world that made them possible stopped existing first.